Hello everyone, so today I'm solving this problem, find kth smallest pair distance. So a pair distance is nothing but for example we take two values 1 and 3, then pair distance is 2, difference, absolute difference, simple like 3 and 1, then pair distance again it is 2. If we take 1 and 1, that is also 0. So we have to find the kth smallest pair distance. Okay, so something like this, let's say. So you can take an example of this. So how many pairs we can make? We can make 3 and 5. We can make 5 and 6. We can make 5 and 6. We can make 6 and 8. So many pairs, right? All of them would be there. Now out of these pairs, we have to find the what would be their differences. So for example, if we take 6 and 8, right? So let's take 6 and 8 here. So what's 6 and 8 making? 6 and 8 making 2, right? So then we have 5 and 8 like that, right? So many pairs are there, all of them you can write. But look at their differences. So if we very first time, let's say 3 and 5. 3 and 5 producing what? It is producing 2, right? 3 and 5 producing difference equal to 2. Similarly, if we look at 5 and 6, it is producing difference equal to 1, correct? So if we put the differences in a line, so 1, then 2, then take an example of here 5 and 6, see here 3 and 5 and 8, it is producing 3, right? Similarly, if we take 3 and 8, what it is producing? 3 and 8 is producing 5, right? So in this way, like now you can see this is our k. If k equal to 1, then this first value would be our answer. Okay, 1 would be answer if k equal to 1. If k equal to 2, then second value 2 would be our answer. If k equal to 3, then this 3 would be our answer. If k equal to 4, then 5 would be our answer. Okay, so basically we have to find the differences of all of them, and we have to find the kth smallest, means the from starting from very small till kth we have to return. Okay, so in this example k equal to 2, so we have to return this value 2, right? So same thing we have to do. Now the main thing is what would be our approach. Okay, so our approach would be simple. We would go to binary search way. Now I will tell you how and how to come to this intuition that we are going to binary search, because we just cannot say blindly that we are going to binary search. There should be some intuition, right? So let's go to first that intuition, that why I'm going for the binary search. So see here, if we look at the absolute difference, so in pair distance, what would be the smallest value? For any value which is low equal to 0, okay, and what could be the maximum value? Maximum value would be the difference between the highest value in the array and the smallest value in the array. So 8 minus 3, so 0 to 5, these are the values, right? These are the absolute difference. Now our answer, for example k equal to 2, what would be the value? So any value should lie between this 0 and 5, including these both, right? So from here we got an intuition that our answer should be somewhere on this line between 0 to 5, right? So this is our low and this is our high, right? This 5 is our high. So if we go in a binary search way, right? If we go in a binary search way, we have to find what all value in the mid comes, and for that mid we have to find the number of pairs. Okay, for example in this case what would be our mid? Our mid would be low plus high divided by 2. So low is 0 and high is 5, right? So what it would be? 0 plus 5 divided by 2. So this would be 2, right? 0 plus 5 divided by 2. Now this would be our 2 only. Now we have to find how many pairs are there in this array which has the value, the pair difference is less than or equal to 2, right? So 3 and 5 is one pair, correct? Because it's different is 2 only. We are looking either less than 2 or equal to 2. So this is one pair. Is there any other pair? Yeah, 5 and 6 is another pair, right? So 5 and 6 is another pair. Is there any other pair? Yeah, 6 and 8 is another pair because difference is 2 only. So let's write it down. 6 and 8 is also there. Is there any other pair? So no other pair. Other pairs, like if we make 3 and 6, then then the value is going beyond the 2, right? Let's say if I am going to 3 and 5, 3 and 6. So in this case difference is 3, right? But we are looking only for the value 2. We have value 2 here. So if we try any other value, we look 3 and 8, obviously this would be greater than this, right? 3 and 5, 3 and 8 is also making 5. So this is also not our value. So how many pairs are there? There are only 3 pairs which are satisfying our condition. So total count of the values which are less than or equal to this mid, they are actually equal to 3. But see here, we are looking for the second k equal to 2 value, but this count is 3, right? So that means this is not a matching one. This is a higher value. We are looking for k equal, if count was 2, then our answer would have come. So if count is 3, that means there are 3 pairs. That means this mid equal to 2 is not the kth value, correct? So what we have to do in this case, if count is high, then we have to decrease our high, right? Just like we do in the binary search, our high would become mid. So let me update it. So in this case, because our count is going beyond the k value, so what we have to do, the value is becoming higher. So in case of higher, what we have to do, in case of higher, we have to update our high value, this high. So far this high was 5, but now high will become mid. Okay. So our high will equal to mid, which is 2 so far, right? So high will become 2 and low is still 0, right? So low is still 0. So what would be mid now? Our mid would be 1, right? Our mid would be 1 because low plus high, 2 plus 0 by 2, right? So 2 plus 0 by 2, it is basically becoming 1 only. Okay. Now we have to check for value 1. Okay. So see here, 6 and is there any value? 3 and 5, which is 2 greater than 1, 5 and 6. Yeah. So 5 and 6 is the one pair which is less than or equal to 1. Okay. So 5 and 6. Is there any other pair? 3 and 5? No. 5 and 8? No. 6 and 8? No. Only 5 and 6. So count equal to 1. Only one pair is there. But our k equal to 2. So this is lesser. Okay. This time this count is lesser. So in case of lesser, what happened in binary search? Our mid would increase, right? So in this case, what will happen? We will update mid, our low thing would be mid plus 1, correct? So let's update those values. So our low would become mid plus 1. So our low would be, mid was 1. So 1 plus 1. So mid would become our 2, right? 1 plus 1. So low is 2, high is 2. So what would be mid? New mid also 2, because 2 plus 2 divided by 2 equal to 2. So I am writing directly 2. Okay. Now for 2 we have to see how many are there. Okay. So as you remember, for mid equal to 2 we already got, it was count was 3, right? So this time mid equal to 2. So count was 3, like 3 and 5, 5 and 6 and 6 and 8. All these 3 are making. So again this count is equal to 3, which is greater than k. So what we have to do now? We have to basically decrease our high, right? So our high would become again mid. Okay. So far all of them are like low is also 2, high is also 2, mid is also 2, right? For k equal to 2, which is again repeating, right? But as we know in binary search, right, we use this while. In while condition, what we check always, we look for while low is less than high, right? But what is happening here? Low is equal to high, right? So while low is less than high, only till that time this would be proceeding. But now this while loop would be broken, right? Because low is actually becoming high. So we will come out of it and we are returning low. Okay. So return low. So low would be our answer basically. What is low? Low is 2. So 2 would be our second value. You can check as well. So see here, 6 minus 8, it is 2. 5 minus 6. So 1 is the first value and then 2 is the second value. See here, you can check 6 minus 8, which is giving us 2, right? Similarly 2 minus 5, this is 3, right? And 2 and 6, so this is 4. So you can say for k equal to 2, our answer would be the second guy, this guy. So in this binary search way we can find this value. I'll show you my code as well. So you can see here I have just written one method here, one utility method, which will give me the count of pairs which are less than or equal to given distance. Okay, so see here I just created one integer variable left. So first of all what I'm doing, look at this while condition. While nums j minus nums left is greater than dist. So basically first of all I am skipping all the values which are making the values which are greater than dist, because we are interested less than or equal to. So till that time I am increasing this left, and then I am making the difference. Okay, this difference will be giving me the total count. See here, for example, if we are looking for, let's say, distance equal to 1, let's say d equal to 1, in this case what will happen, 5 minus 2 is basically 3, so we will increase. Let's say our left was initially here, 5 minus 2 is 3, but we are looking for distance 1, then our left would come here. Now see here, 6 minus 5, it is 1. So now it is making a valid thing. So that is why we are increasing this left value. Okay, so now you can see here, till the time it is greater I am increasing left, and later I am making the difference, because j minus left, whatever index is, all those values in this interval would be smaller only, or equal to or smaller only, right? Because the array is sorted. This is as simple as that. And finally I am returning the total count of the such pairs which are less than or equal to this distance. Now this method I would be using in my binary search. So see, this is my binary search function. So initially see here I am sorting the array, and then see here I got the low equal to 0 and high equal to the biggest value minus a smallest value, because this would be the range of our pair distance, right? So now see here, while low is less than high, we are calculating mid, and then I'm getting the number of pairs with the mid distance. And now I'm checking here, if this count is less than k, that means we need more counts, right? Because either looking equal to k, so low equal to mid plus 1. Otherwise, if count is greater than k, that means we need the lesser count. Then I'm making high equal to left side till mid. Then finally we will returning this low, because low would be having the value of the kth element. So let me execute this code. Yeah, so it is accepted. Let me try to submit it. Yeah, so it is submitted 81.12% faster. So thank you for watching this video. And guys, not only this question, but we should get the intuition that whenever we are finding a range where our answer might be there, okay, like low and high we got, right? So this gives a intuition, then we can go for the binary search paradigm. Okay, so thank you for watching the video. If you guys have any concern, please make a comment over there. Thank you.